All right, let's dive in. We've got some interesting source material here focusing on how money grows, specifically getting into uh, simple versus compound interest.
Yeah, and the goal here, as I see it, isn't just reciting formulas.
Exactly. We want to unpack the why behind it. What's really happening under the hood when we talk about these two types of interest? What makes them tick differently?
Okay, so the sources start us off with the basics, right? You've got the principal, that's your starting cash, the initial amount.
Right, what you put in or borrow.
Then there's interest, which is the extra bit, the cost of borrowing, or the reward for lending or investing.
And the total is just called the amount, principal plus that interest. Simple enough.
Amount equals principal plus interest. Got it. So the first type they explain is simple interest, SI.
And the key thing they stress about simple interest is
It's calculated only on that first original principal. Doesn't matter how long it's been or how much interest you've already earned.
okay, so if the rate is, say, 10% per year on $1,000.
You get $100 interest that first year. And the second year, still $100. Third year, $100 again.
Because it's always based on that initial 1,000, the interest amount itself is, well, simple. It stays the same.
Exactly. It's constant each period. Now, contrast that with compound interest, CI. This is where things get more dynamic.
Okay, how so?
With compound interest, the interest earned isn't just set aside. At the end of a set time, they call it a conversion period. That interest gets added back to the principal.
Added back, so your base amount,
Well,
it actually increases.
precisely. That new, bigger amount becomes the principal for the next period's calculation.
Okay, that sounds like the crucial difference. Let's use their example. The 1,000 at 10% for 3 years. Simple is easy. 100, 100, 100, total interest 300, end amount 1,300.
Right. Now, compound, year one. 10% of 1,000 is 100 interest. Same as simple so far. Your amount is 1,100.
Okay.
But here's the twist. For year two, you don't calculate interest on the original 1,000 anymore.
You use the new amount, the 1,100.
Yes. So 10% 1,100 is $110.
Whoa, okay, so you made an extra $10 in interest just because the first year's interest was included.
That's it exactly. You're earning interest on the previous interest.
Right.
So after year two, your amount is 1,100 plus 110, which is 1,210.
I see where this is going. So for year 3, the principal isn't 1,000, it's not 1,100, it's now 1,210.
You got it. And 10% of 1,210 is $121.
Huh. So the interest earned went from 100 to 110 to 121. It's growing each year.
Right. And the final amount after year three is 1,210 plus 121, which totals 1,331.
So comparing them side by side, simple interest gave 300 total, end amount 1,300. Compound gave, let's see, 100 plus 110 plus 121. That's 331 total interest. End amount 1,331.
In that extra $31, purely from interest earning its own interest. That's the compounding effect in action.
That makes sense. It's like a snowball effect. Compound is like the snowball getting bigger and thus picking up more snow as it rolls.
That's a great analogy. The sources show this step-by-step calculation method. Find the interest, add it back, use the new total for the next step. That's how you manually see the principal growing.
And that conversion period thing they mentioned?
Yeah, that's just how often the adding back happens. Could be yearly, like our example, or maybe half-yearly, quarterly.
Mm-hmm.
The more frequent the compounding, generally the faster it grows, though that's getting into more detail than just the core concept.
Okay, so boiling it all down, the fundamental difference, the big takeaway from these sources.
It really comes down to whether that earned interest gets reinvested, gets added back to the principal. Simple interest doesn't do that. The principal stays fixed. Compound interest does do that, making the principal grow, which in turn generates even more interest next time around.
It's that feedback loop. Interest creates more principal, which creates more interest.
Exactly. And while the sources go into other things, like different rate calculations, or even depreciation, which is sort of like negative compounding on an asset's value.
The core mechanism is that changing base value.
Right. That's the engine behind it.
Okay, that clarifies a lot. So here's a final thought, kind of building on this idea from the sources. If adding your financial gains back into the pot makes things grow unexpectedly faster, where else could that principle apply?
Interesting question.
Yeah, like what if you consistently reinvested the results of your learning, or the progress made in building a skill, or even nurturing relationships? Could applying effort to the results of previous effort lead to similarly surprising compounding growth in other parts of life? Something for you to think about.